Hello everyone, welcome back to my YouTube channel. This is Sir DL and welcome to the Aliens Blog and Math Tutorial. For today, we are going to discuss addition of radicals. We are going to study addition of radicals. What are the objectives of this lesson? Number one, discuss addition of radicals. And number two, solve and simplify addition of radicals. We are going to simplify and solve addition of radicals and we are going to discuss it today. Always remember, if you think you can, you can. If you think you cannot, you are right. If you think you can, you can. If you think you cannot, you are right. How to add radicals? To add radicals, the indices and what is inside the radical called the radicand must be exactly the same. If the indices and radicands are the same, then add the terms in front of each like radical. To add radicals, the indices and what is inside the radical called the radicand must be exactly the same. If the indices and radicands are the same, then add the terms in front of each like radical. If the indices or radicands are not the same, then you cannot add the radicals. Okay, let's have an example. So 2 to the square root of 5 plus 2 to the square root of 5. To add radicals, the indices and what is inside the radical called the radicand must be exactly the same. As you can see, we have the same indices. Both of them are square root. And we have the same radicand, which is 5. That means we can add these two because the indices and the radicands are the same. Square root of 5 is square root of 5. But it's 2 plus 2. That is 4 the square root of 5. We just simply copy the square root of 5, then add the terms 2 plus 2. That is 4 the square root of 5. This is our final answer. Another example, 10 the square root of 2 plus 16 the square root of 2. As you can see, we have the same indices, that is a square root. Then we have same radicand, which is 2. Square root of 2, square root of 2. We have the same indices and same radicands. That's why we can add the terms beside it. That is 10 plus 16. That is 26, then copy the square root of 2. 10 plus 16, 26, then copy the square root of 2. So the final answer is 26, the square root of 2, because we cannot simplify 2 square root of 2 anymore. Another example, what if 3 the square root of 2 plus 2 the cube root of 2? Do we have the same indices? No, we don't have. Because it's square root, then it's cube root. That's why if the indices or radicands are not the same, then you cannot add the radicals. That's why our final answer is also the same. 3 the square root of 2 plus 2 the cube root of 2. Because our indices are not the same. Okay? Next one. 3 the square root of 2 plus the square root of 8. Do we have the same indices? Yes, we have. Both of them are square root. Do we have the same radicand? It is 2 and it is 8. We don't have, but wait, we have a note. There will be times that you need to simplify the radicals in order for you to have the same radical. As you can see, the square root of 8 has a perfect square factor. And those are, as you can see, we have 3, the square root of 2. The factors of 8 are 4 and 2. And as we all know that the square root of 4, we can simplify square root of 4. That is 3 the square root of 2 plus the square root of 4 is 2. Then we can, and the square root of 2 will remain. We now have same indices and same radicand. We just simplify the square root of 8. We can simplify the square root of 8 by the means of getting the factors. And one of the factors must be a perfect square factor, that is 4. And 4 is a perfect square, 4 times 2. That is the square root of 8 pa din. So the square root of 4 is 2. Then we copy the square root of 2. We now have the same indices and same radicand. That's why we can add the terms. 3 plus 2, that is 5 the square root of 2. Our final answer is 5 the square root of 2. Next one. 4 the square root of 72 plus 2 the square root of 8. We have the same indices, but we do not have the same radicand. But 72 and 8, square root of 72 and square root of 8 can be simplified by the means of looking for a factor. And one of the factors must be a perfect square. What are the factors of 72? Which is a perfect square and which is one of them must be a perfect square. And what are the factors of 8? And one of them should be a perfect square. It goes like this. We have here now 36 can be factored out by 36 and 2, and 36 has 36 is a perfect square. 8 can be factored out by 4 times 2, and 4 is a perfect square. That's why 36 times 2 is 72. 36 is a perfect square. The factors of 8 are 4 and 2, and 4 is a perfect square. What is the square root of 36? That is 6. The square root of 4 is 2. The square root of 36 is 6. The square root of 4 is 2. We can now multiply both terms. 4 times 6, that is 24. 2 times 2, that is 4. We can now simplify this because both indices and radicands are the same. So we can combine these two. 24 plus 4 is 28, the square root of 2. We just copy this radical. That is the final answer. There will be times that you need to simplify first the radicals in order for you to have the same radical. Another example, 5, the square root of 3 plus 3, the square root of 27 plus 4, the square root of 12. We have the same indices, but we do not have the same radicands. That's why we need to simplify first. We cannot simplify the square root of 3 because it's simplified already. We cannot have factors for 3, which is one of the factors is a perfect square. For the square root of 27, we can factor out 27, and one of the factors must be a perfect square. We can also factor out 12, and one of the factors must be a perfect square. It goes like this. We copy 5, the square root of 3. Then 3, the square root of, the factors of 27 are 9 and 3, and 9 is a perfect square. The factors of 12 are 4 and 3, and 4 is a perfect square. We can simplify square root of 4. We can simplify square root of 9. Next, 5, the square root of 3 plus 3. The square root of 9 is 3. The square root of 4 is 2. So we need to multiply these two first. Again, the square root of 9 is 3. The square root of 4 is 2. Then after that, we will be multiplying these two. 3 times 3 is 9. 4 times 2 is 8. We copy this one. 3 times 3 is 9. 4 times 2 is 8. We can now simplify this because we have the same indices and we have the same radical. What is 5 plus 9 plus 8? That is 22, the square root of 3. We will just be copying the radical because we will just be adding the terms beside it. 5 plus 9 plus 8 is 22, the square root of 3. I hope you were able to follow our simple instruction for today. Always remember, mathematics will always remind us that in every problem there is a solution. Always remember, mathematics will always remind us that in every problem there is a solution. Thank you for watching, everyone, and may God bless you. See you on our next tutorial.